All right, everybody, it is time. Please welcome Mr. Dom Larkin, who will be speaking on West Point's UAS integration.
So hello, everybody. I'm Dom Larkin. I'm here with my colleagues, Cadet Audrey Aldrich sitting in the front row here, and Rob Cariello. We're here on behalf of the Robotics Research Center. I'd like to thank you all for being here and giving us this presentation to present our work on ATAK and in some depth our use of UAS tool during the summer training. You know, if at any point we're covering anything that you want to engage us more, if we don't have time during the questions, please reach out to us. We'll be around the rest of the afternoon and tomorrow. We got the hardware up here if you want to take a closer look at it after this meeting. Cadet Cariello is going to take it down to the demo room, which is the last room on the right, and you can go in there and maybe get your hands on a closer look at some of the hardware. So this is the agenda. I'm going to talk a quick introduction to the Robotics Research Center. I'm going to give an overview of TAK at West Point, and I'm going to talk briefly about a plugin we're developing for mission planning and autonomy interfacing, and then Cadet Rob Cariello will take over and give you some in-depth coverage of our use of UAS tool during summer training. And then we hope to have a couple minutes for questions at the end. So the Robotic Research Center is about 20 people at West Point, 20 researchers. We're a mixture of active duty military officers, DoD civilians, contractors, and we have some visiting researchers. And our main focus is going after trying to fill the gap and to mature some of the robotics technology, getting after the warfighting applications, and with a specific focus towards the Army's needs and issues. So a quick overview of TAK at West Point. A lot of our TAK usage we divide into two categories. Some of it's tactical, where we have people in the field using it to do tactical operations. Other times it's research focused. And we tend to bleed this together a lot. Sometimes the only difference is whether, you know, the number one priority is a tactical or training objective, or is the number one priority a research objective. So we're very tightly coupled with these end users. One of our sales pitch for our end users, these are cadets. They're very heavily interested in coming up with a solution, and they're not hindered by many years of experience. They don't know how this has been done for the past 10 or 20 years. So they're taking a fresh look at this technology. They're getting a fresh look at military tactics, and provides a really good research platform for us. So TAK development at West Point and research began in earnest in 2018 when we sent a cadet on an internship. She came back with the ability for us to stand up our own TAKServers and do TAK development, and we've been doing this to some degree off and on since 2018. We then developed this TAK to ROS bridge. What this did was enable our autonomous robots to both send and receive TAK messages and respond to them. This involved into a system where we were tasking robots over ATAK, much like you would task a normal person. So without a plug-in, I would send my graphics, or I would send messages to the robot, and the robot would follow a path. This is further involved into this new plug-in that we're developing. We're early in the stage of it, and I will go in some detail about this mission planning to robot plug-in. On the application side, we have our, the Robotics Research Center sponsors the Future Applied Systems Team Club at West Point. Cadet Cariello will go into some detail about this later. He's been involved in it for many years, and he's one of the leaders of this team. And they're going after this intersection of military tactics and future technology. But the big change and the big emphasis this summer was our senior leadership mandated TAK involvement in cadet summer training. So we rapidly stood up, and Rob Cariello is going to go into some depth on this, the UAS tool usage with 18 drones we built. But they were also using it for battle tracking. If you went into their tactical operations center for all of summer training, and you would see WinTAK providing them their common operating picture for battle tracking and sharing graphics. So this plugin I'm going to talk about real quick here, we've created some initial capability on it. There's a lot more to do on it, but this is in support of what we're calling our PTAR effort. This is Planning, Execution to After-Action Review tool set. There's a set of tools used for enabling robots to be part of the planning, execution of missions all the way up to and including the AR after the mission. The plugin right now is primarily hits the planning and execution phase. Purpose of this, again, is to lower cognitive load of the end users and to get away from this teleoperation and waypoint driving that's going on. So how we're solving this problem, we're using TAK as a planning tool. TAK sends the TAK messages and graphics to the robot. The robot parses these messages into a behavior tree, and then the robot takes off and does its autonomous behavior in support of this mission task. And then here's a quick picture of what the plugin looks like. I'll give you a real quick idea of what this mission may be for some of you who are not very familiar. So the blue arrow is where the operator is. Right next to the blue arrow, you'll see there's a circle there that represents the robot's location. There's some operational graphics. There's 2 white vertical lines that represent phase lines. I'll call them phase line 1, phase line 2. There's a polygon representing a named area of interest. So a typical use case here would be the robot will go past phase line 1, stop at phase line 2, observe known area of interest for any activity, and report it up. So the top here shows the graphics and the map. In the bottom left of this plugin is our status. These are the messages we're receiving from the robot. Right now, these are fairly generic messages. In the future, you might get messages where the robot's reporting them now at phase line 1. I'm in position, or I've observed 2 people in the NAI. In the center is where you interact with the robot. So you can see here, robot call sign is Dozer. This plugin has evolved now to where it's a drop-down, so you can control multiple robots and just select the robot you want from the drop-down. And then we have the 4 buttons across the bottom where we can either approve or deny a robot action. You may get a request, okay, I'm at phase line 1, you want me to continue, yes or no. We can either approve or deny the action. And then the 2 buttons below allow us to either to pause the robot in the mission or allow it to proceed. One of the challenges in these missions is synchronization of effort. In most military operations, it's the biggest challenge, synchronization. Somebody's being held up and slowed down. We need to be able to do this also for the robot. And the last piece we have, I think, is a requirement for all autonomy for quite a while yet, because it tends to be a little bit unpredictable, is our e-stop button. So if the robot's going to cause harm to itself, other people, or equipment, we can hit the e-stop and just shut it down. So this is our PTAR plugin that we're working on. Dr. Aldrich has taken up lead on this effort. If you want to engage her about any of this later on, this interaction of ATAK to autonomous systems is one of our main focuses at the Robotics Research Center. So I'm going to go ahead and introduce Rob Cariello here, who's going to go ahead and talk a little about the future applied system, and then he'll go into depth about the UAS tool usage. So Rob.
Thank you. Good afternoon. I'm Cadet Rob Cariello. I've been working with the Robotics Research Center for the last couple of years through our Future Applied Systems team. We're a platoon of cadets at West Point that go out in our free time to do field training exercises, incorporating in emerging technologies, whether that be robots that are coming out of the research center or EW systems, new TAK plugins, kind of all-encompassing technologies. And we're really trying to find the gaps in the current current infantry tool set and see how we could use technology to address those. So for the rest of all cadets at the Academy go through a couple different summer trainings. Their Robotics Research Center supports 2 main of these summer trainings. There's cadet field training. This is for cadets that just finished their first year at the Academy. This is like basic small unit tactics, introduction to how to use their radios, stuff along those lines. We're talking about fire team level things. And then we have cadet leader development training. This is platoon operations. It's more complex. They're out in the field for longer. That's for our more experienced 3rd and 4th year cadets. And like I said, we're going to be focusing on cadet field training. That's where we were asked to provide these UAS. So we were approached by Hire, and they said we would like 5 UAS per company, with 3 companies in the field at a time. We want these to be low cost, somewhat attritable, so only $3,000 per UAS. They needed to be autonomous to reduce the warfighter load. Obviously have a long flight time for UAS of its size and a pretty decent range. They had to be man portable. We're talking about using these in a field training exercise. Also, because of our airspace requirements, they had to be NDA compliant. And we were only given 2 hours to train these cadets and turn them into pilots, which is a tall task on its own. If all that wasn't bad enough, we had to have these delivered in a month. So now here's what we're able to do. We built 18 of these UAS for a little over the target price. They can fly fully autonomous with a 45-minute flight time. We've pushed these out to 2 kilometers. We believe they could go further than that. And they are man-portable, we had some propeller breakages. Obviously, they're a little bit big. We're going to address those issues a little bit later. Fully NDA compliant, and you could train on it in less than 2 hours. All of this was done in a month. So the reason we were able to get this done so quickly, we started prototyping immediately. In 72 hours from the time of the request, we had our first prototype built. This was really a proof of concept. We went through the engineering design process, but we went through it very quickly, keeping in mind our time restraints and our budget. We decided to include an onboard computer. We're using a Raspberry Pi 4B for some simple autonomy packages in the future. We decided to use an Android end-user device as our ground control station because we wanted these cadets using ATAK anyway. And then instead of having to carry an extra controller, worry about the batteries for that, they're just using that Android. And we also considered an analog option, kind of more similar to the standard FPV drones you're seeing in Ukraine, but we went with a digital data link. That way we could make sure this is a future-proof design for future experimentation. What you can see here is our hybrid aerial reconnaissance vehicle, Harvey for short. All the avionics are housed in that 3D printed kind of lid on top. That's our flight controller, onboard computer, radio module. We have our battery in a slightly protective cage slung underneath. And then we have a Raspberry Pi cam fixed at a 45-degree angle, mainly to save on cost. Our ground control station, we're talking about, very simple, just a Pelican case with a radio module inside, hooked up with via Ethernet to our Android end-user device. The way we were able to get these built so quickly is we set up a factory down in our lab. So we had 15 Robotics Research Center personnel, 2 personnel from our engineer support group. We had some soldiers from 101st Airborne come help support, and we were able to build 18 of these in only 2 weeks. Now that we have the hardware all set up, it came time to decide on the software. So, we already knew we were using the Android end-user device. That kind of led us to 2 main options here. We had Q Ground Control. They have an Android release. And the reason we consider this is we have a lot of experience using Q Ground Control and similar ground control applications around our lab, especially for our, more experimental UAS. But then again, we knew we were going to be using ATAK, and UAS tool is a nice shiny option there as well. And we did end up settling on UAS tool, and that was for a number of reasons. One major reason is that we knew we could integrate a variety of UAS onto this tool. In the past, we've flown a Skydio X2D over UAS tool, and we knew that basically any Mavlink drone could be flown over it. We also had outstanding support by the UAS tool team. There were a couple roadblocks we hit, especially with our inexperience with the software. We were able to reach out, and they were able to kind of give us recommendations or workarounds, and we were able to get all the functionality we needed out of it in such a short time frame. We found the user interface, especially for a novice pilot, was extremely intuitive, and I'll get into that in a minute. And then, along those lines, we found that the parameters, especially safety parameters like fail-safe criteria, geofences, we found that that was a little harder to access than something like Q Ground Control where, your fail-safe criteria is only 2 button presses away. And for our novice, undertrained, only trained in 2-hour pilots, that is a big plus for us. So again, with that 2-hour training block, we had to keep it very basic. There were 4 main functionalities we needed to train these pilots on: switching between flight modes, flying with virtual joysticks, being able to see the map and your drone feed at the same time, and then plotting and executing waypoint missions. UAS tool does a lot more past this, but we needed just the bare minimum to get these pilots safely, flying during their exercise. So this is one of the slides we have directly from our training slides for the cadets. And here I want to point out, like I said, that kind of intuitive interface. Everything you need for safe operations is right there without digging into a menu, right? I mean, being able to see where your drone is and seeing your drone's home, and seeing those separately, because sometimes you hit return to launch, your drone doesn't go where you expect your drone to go, and knowing where it views its home is critical. Obviously, battery status right there in the top left, and then the drone's location there, given as a 10-digit grid, is huge, not just for safe UAS operations, but to use these and employ them tactically, knowing where your drone is to be able to call for fire, identify where you're seeing enemies moving around, or anything along those lines is absolutely critical to actually make it useful in a training event. This is again from our training slides. The notification logs in UAS tool are outstanding. In Q ground control, it could be kind of easier in a different app. It could be kind of easy to miss those notifications. But you see, down bottom kind of center of the screen, you have a notification bell with a big red, circle on it. Everyone with a phone knows what that means. They know that means, oh, I have a notification, I should check that. And when we would get a call over the radio from our pilots in the field going, hey, why is my drone not working? Being able to have them read off the notifications, almost always we're able to find a solution and help them repair it remotely. The mission menu, like I said, in UAS tool, it is outstanding. It's just drag and drop, just like you would plan a route for an individual, same way with your UAS. Now here is where we, got stuck on a couple, hitches here. You see that big play button next to the Q button? We found that if we hit that play button, our UAS would flip over on its back like a turtle. So we had to teach our pilots, don't hit the play button when you want to execute a mission. We would have to have them arm the drone in position hold mode and then change into guided mode later. But again, we only had a month to get these things in the hands of these cadets out in the field. We didn't have the time to figure out what was going on there, but we just had to find the workaround. Now, like I said, I keep reiterating it. We only had 2 hours to train them. And here's everything we had to cover. I mean, not just the rules and regulations, both military and civilian airspace, but TAK onboarding. I mean, we heard yesterday at the public safety brief how long it could just take to onboard someone onto TAK. We had that same issue with our cadet pilots. Familiarization with our own system here, and then how to use UAS tool. But it goes further than just how do I use UAS tool, like what do all the buttons do? But when it comes to flying UAS, I could know what the buttons do and still crash the thing. So making sure they were a proficient pilot was critical here. We trained 21 cadets at a time, many of which were unfamiliar with everything we were teaching. So when I say we started from the basics and worked our way up, all of that had to fit in our 2 hours. The way we were able to do that is we broke our 2-hour training session into 2 smaller 1-hour sessions. First one covered all the rules and regulations, and it was basically everything we could do indoors. So spinning them up on TAK, familiarizing themselves with the vehicle itself. We had them in small teams of 5, so every team of 5 had an end user device and a UAS with them. And we just had them pass it around. Everyone got a chance to work through everything they could indoors before we took them outside, where each pilot was given 15 minutes to fly with joysticks, to plan and execute a waypoint mission, and then once they were done and we validated them, they would teach the next pilot in the queue to make sure that they reinforced all that knowledge in their head. Now, I want to go through a couple of the challenges we faced, and especially with the TAK development community we have here, I want us all to try to brainstorm ways we could use TAK to solve a lot of our issues that we faced. We put them in 3 broad categories. Institutional, those are Army, FAA, West Point rules that we kind of had to navigate. It's also just the nature of military training and what that means. We had design challenges, which were issues with our vehicle itself or the way we integrated that vehicle with TAK, and then field expedience challenges, just all the issues that come with making a system and sending it out into the woods far away from the lab. Going into some of these institutional challenges, a big one is we got these cadets when they were halfway through this summer training. So they're already exhausted. They're already hungry. They've been, sometimes we got them right out of the rain. Trying to sit down anyone, especially a soldier, and teach them how to, use TAK when they're in that mindset just adds on to the difficulty and confusion. There was also the last minute integration. It wasn't helped that we only had 2 hours to train these guys. They basically had to find a time to squeeze us in for this training, so we didn't have the time to get multiple touch points with these pilots before they went out on their training exercise. The other thing here is that every pilot that we were training had another role in the exercise. Most of them were squad leaders, so they had 8 to 10 other cadets that they had to worry about, keeping them safe, making sure they're doing the right thing. So when I have someone who's a squad leader and a UAS operator, that is a ton of cognitive load. And trying to work to reduce that cognitive load was, a big challenge of ours. And then their inexperience with air coordination. These pilots were sharing their airspace with manned aircraft as well. So we had to come up with a complex series of reports that had to be sent up when they launched their UAS, when they brought it back down, so that we could make sure all UAS were grounded by the time helicopters were flying overhead. When it came to the design challenges, we were mass fielding a prototype. There's no doubt about that. These would go out into the woods, something would break. We had all the supply chain challenges that came with, getting NDA compliant parts in a timely manner. So, these would come back broken. Overnight, we'd have to fix them, or within a couple hours during the day, and bring them back out to the patrol base so that platoon's not missing their UAS for too long. And that often meant that when something went wrong and we didn't know why it went wrong, we couldn't put the time in to figure out what went wrong. So a lot of times it came, we don't know what happened, it just fell out of the sky. We're like, okay, new parts on there, back out, with a little flight test to make sure it was good by the time we were sending it back out. And then, again, our inexperience with UAS tool was a big hindrance on ourselves. Simple stuff like compass and gyro calibration. We just didn't have the time to figure out how to do that in UAS tool. So what would happen is we would calibrate it in a different software, send it out to the cadets, and hope that they didn't get, calibration dump. And whenever they did have a calibration dump, we'd have to go out there and fix the problem for them. Now, the field experience challenges. There were 16 platoons in the field at a time. Each one of those platoons had a UAS with them, and they were in almost a 16 square mile training area. Patrol bases, by doctrine, are in the nastiest, worst, most difficult to reach places. So when we got a call that, hey, something's going wrong, why won't my drone take off? And we'd have to go out there. We were trudging through the worst terrain, and we didn't know what we needed to bring with us. Sometimes we'd have, a radio chip just go dead, and we're not carrying spares of those. So it was kind of like a surprise every time we got to a patrol base to figure out, oh, this is a problem I've never seen before. I didn't plan for this. So there's a lot of calls back to the lab, sending a Humvee out with extra repair parts to try to fix these out in the field or bring them back to fix them in the lab. Also, the terrain was not always conducive to UAS flying. Again, we're talking about patrol bases. Good on the cadets. A lot of their patrol bases had great overhead cover, so they couldn't be seen from the sky. However, that also means they can't take off their UAS, right? Sometimes there were just no holes or no flat ground to take this thing off, so they would have to walk hundreds of meters to try to clear an LZ. The geofencing was also a big issue. So we put a geofence on every one of our UAS to make sure they're not flying out of our training area. However, we made one big geofence for every single platoon, which meant if 2 platoons were flying in the same area, we could easily have a UAS on UAS collision. And that was something we kind of just said we'll live with. They're cheap enough. And we were having the platoons talk to each other just over regular VHF comms to figure out, make sure they're either keeping altitude separation or time separation when they're flying in the same area. Now, overall, this was a hugely successful training event, not just for our lab, but for the entire academy. We trained over 150 pilots on how to fly using UAS tool, and over 1,000 cadets were experienced to UAS operations and TAK. We had over 70 tactical flights during the exercise. This isn't including any of our training flights. And those tactical flights included, call for fire, regular reconnaissance, route reconnaissance. And now, going forward, we have 18 fully customizable drones for our future experimentation. This had a lot of visibility. So we have multiple general officers at West Point, all the way up to our 3-star, all got to learn about, TAK and UAS, and are very happy with the outcome of thousands of cadets, getting this kind of exposure. In the future, we hope to turn our 18 Harveys into an autonomous swarm, and we're publishing not just our findings from fielding this many home-built UAS in such a short time frame, but also publishing the actual bill of materials, if anyone, to DoD and research universities to help kind of democratize the airspace and get more UAS out there. We are making upgrades to our current design, and we're going to be coming out with a new design that's smaller, sturdier, more for like the squad level. And that new design is actually going to be integrated into our Intro to Technology course that every cadet takes in their first year at the academy. So every cadet upon graduation will have been on a team that builds and flies a drone over UAS tool. At this time, we'll take any questions that you have. And after this, I'm going to be over in the demo room in case we aren't able to get to anything.
So, yeah, if there's no questions, let me talk a little about CLDT. So he talked about cadet field training, which is usually their first exposure to field training out. We also did support to CLDT, which is the upperclassmen. So with them, we outfitted them with TAK. They were flying, it was basically a lane where they did a force on force. They had one element attacking a defending element, and we provided them with autonomy. They had anywhere from 2 to 3 UAS for the most part on each element, and they had a ground robot, or 2 ground robots supporting them at one point. And then they were battle tracking with TAK. They were using it to so some of the usages were the battle tracking. So the graphics tend to be very popular. Is that the fact they can draw these graphics and share them across to everybody proved to be very popular. The enemy being able to drop suspected enemy locations, we saw some usage of this. All this occurred with virtually no TAK training. We basically gave them the TAK. Would you give them about maybe a minute or two class on it?
Set their call sign, and that was it.
Yeah, we had them set the call sign on it, gave it to them, and said go. And we kind of saw the same thing with the UAS tool. So in CFT, we gave them these TAK. We gave them a class on the UAS tool. But they didn't stop there. They started using the TAK for other things, to create the graphics and for planning capability. So we're a huge advocate of this community. We've been kind of on the edges of it for years. You're filling a need for the Army. You're filling a huge need for us right now. So I'd like to thank everybody here who's a part of this. And the UAS tool specifically, the fact that it's already integrated into this tool. Enabled us. It was a huge enabler for us to meet our budget and our timeline. So thank you all for everybody who's been contributing to this. And any questions? All right. So thank you very much.